Welcome to Crashcast Java, where we break down complex Java concepts into bite-sized, easy-to-understand pieces. I'm Victor, and joining me today is Sheila. We're excited to dive into a topic that often confuses Java developers: the volatile keyword and thread visibility.
That's right, Victor. Today we're going to unravel the mysteries of the volatile keyword and explore how it affects thread visibility in Java. Whether you're new to concurrent programming or looking to deepen your understanding, this episode is for you.
Let's start with the basics. Sheila, can you explain what we mean by thread visibility?
Certainly, Victor. Imagine a busy coffee shop with multiple baristas working simultaneously. Each barista has their own workspace, but they all need to know when a new order comes in. Thread visibility is like ensuring all baristas can see the latest order information, even if another barista made changes to it.
That's a great analogy, Sheila. In Java terms, thread visibility refers to the ability of one thread to see changes made by another thread to a shared variable. Without proper visibility, threads might work with stale or outdated data, leading to inconsistencies in our program.
Exactly, Victor. This is where the volatile keyword comes into play. It was introduced in early versions of Java to help address these visibility issues. The volatile keyword ensures that any read of a volatile variable will see the most recently written value.
Interesting. So, how does volatile actually work to solve this problem?
Well, Victor, when we declare a variable as volatile, Java ensures that any write to that variable is immediately made visible to all threads. It's like putting a big screen in our coffee shop that instantly shows the latest order to all baristas.
That sounds useful, Sheila. Can you give us a real-world example of when we might use volatile?
Certainly. A common use case is for flag variables in multi-threaded applications. For instance, imagine a long-running background task that can be stopped by setting a Boolean flag. By making this flag volatile, we ensure that when one thread sets it to true, all other threads will immediately see this change.
That makes sense. It seems like volatile could be a simple solution to many concurrency issues. Are there any limitations or common pitfalls we should be aware of?
Great question, Victor. While volatile is indeed useful, it's not a silver bullet. One important limitation is that volatile only guarantees visibility, not atomicity. This means it's great for single operations like reading or writing a Boolean, but it doesn't help with compound actions like incrementing a counter.
Ah, I see. So for more complex operations, we might need to look at other synchronization mechanisms, right?
Exactly, Victor. For operations that need to be atomic, developers often turn to the synchronized keyword or classes from the Java util.concurrent package, like atomic integer or atomic Boolean.
That's really helpful, Sheila. As we wrap up, could you summarize the key points about volatile and thread visibility?
Certainly, Victor. The volatile keyword in Java ensures that changes to a variable are immediately visible to all threads. It's useful for flag variables and simple shared states but doesn't guarantee atomicity for compound operations. Developers should understand its limitations and use it appropriately alongside other concurrency tools.
Excellent summary, Sheila. For our listeners who want to dive deeper, we recommend exploring these three advanced topics: the Java memory model, the happens before relationship, and how volatile interacts with the final keyword.
Great suggestions, Victor. These topics will give our listeners a more comprehensive understanding of concurrency in Java.
Thank you, Sheila, for this insightful discussion, and thank you, listeners, for tuning in to Crashcast Java. If you found this episode helpful, please subscribe for more deep dives into Java concepts. Until next time, happy coding!